For our first session in this room, we have J.Rosenbaum, who is an artist working in augmented reality, machine learning, and contemporary art. And she's going to talk to us about her creepy, frivolous, and beautiful art made with machines.
Hi, everyone. Thanks for coming. And thank you very much, Ewan, for the nice introduction. Art is seen as an exclusively human avenue of self-expression. But the art we're starting to produce with machine learning shows limitless potential for those willing to grasp it. It's incredible. And now the technology is moving so fast, it's almost blinding to keep up with. Literally, people were posting cool projects last night, and I'm saying, no, stop, I can't add any more slides. That's it. It goes in the next talk. Python's the lifeblood that weaves through the machine learning community. And we're so fortunate because it's a really accessible language, and it's very comfortable. It flows very well. It's readable. You can pick it up. I came into this with very little programming experience, and I'm blown away by all the ways that Python's woven into everything I create, from 3D modeling in Blender to every single machine learning project I'm currently working in. One of my favorite aspects of machine learning is when the tools to create are released into the wild, when the information is disseminated to the point where everyone can explore and create their own works, when AI leaves the lab and the internet gets involved. That's when the most exciting developments start happening. The trend I see over and over is when the technology comes out and goes viral, it's because people discuss how creepy it is and how grotesque. They see the silly and the weird, and they're satisfied if not comforted, and they seek to learn more. Then further development takes over, and artists become involved. And this previously creepy and silly technology moves into the realms of higher art. I love seeing the frivolous, creepy, and ridiculous uses of machine learning because I feel that's where the greatest progress into human styles of thinking will be made. I'm obsessed with machine learning. For me, though, it's about the art and the incredibly frivolous projects. Those are what really delight me. Janelle Shane is known for using neural networks to create paint samples and name pets. She also calls for crowdsourced input for her neural network creations, whether it's Halloween costumes or the first line of your favorite novel. She feeds the data sets into her neural networks and watches as it learns for good or for evil. Janelle Shane works with TensorFlow and Torch using char-RNN, character-based recurrent neural networks. Some recent projects include generating fish names and D&D creatures. The real-world weirdness of humanity seems to work especially well with the weirdness of neural networks. Botnik's another fun example. You've probably seen it online. A few of their things have gone viral. They train predictive text keyboards on scripts, books, advertising, and they have people work with those keyboards to create entire show scripts. They create Halloween tips, ads, romance novels, shark facts, and anyone can join their Slack and become a contributor. I've worked with Botnik. What's interesting about this is that while the content possibilities are driven by a computer, humans are pulling the strings. It's so true, though. I mean, really. All of this tech is available to anyone with a GitHub account and some understanding and patience. We're seeing the highbrow combined with the lowbrow, the sacred and profane, the serious and the ridiculous. And I feel that this openness, this sharing, is what leads to more and more breakthroughs. Not only are we collaborating with our computers, but we're collaborating with people all over the world. This collaboration is at the heart of cyber art. Deep Dream has become a tool used by millions to create disturbing imagery of their very own. The process, the sharing, the discussion around the images is part of the art, not necessarily just the works themselves, but the possibilities inherent in the concept of allowing a computer to dream psychedelic images of your work. Everyone has the power to create these images, just as everyone has the power to pick up a paintbrush or take up a camera. What you do with it depends on your understanding and whether you use the standard options or work with the code to create something unique and startling. Cyber art can be a great equalizer. The tools are available to everyone, but what you do with it, that's the question. That's what transcends the work. Like all art, it's easy to start, but difficult to master. Deep Dream was a leader in the way we look at generative art and machine learning. It made machine learning an accessible visual thing for everyone to embrace. Deep Dream was the first snowball in an avalanche that started a lot of work in neural network imaging and art. I love that frog so much. Puppy slug is the term given to the bizarre creatures that Google Deep Dream comes up with. A horrifying melange of psilocybin-induced critters with too many legs and dog heads and bird bodies, snail shells and eyeballs. Deep Dream was many people's introductions to machine learning, and they used it to create nightmarish selfies and food pictures. I nearly put googly eyes all over my face just for this talk. I didn't, but I nearly did. Most people online use the default convolutional neural network Caffe Model Zoo. A CNN can only use what it's trained on, and Caffe Model Zoo is trained on animals. In fact, there are so many dogs and birds that it can't help but be reinforced. In a way, it's got confirmation bias. It sees something, and each layer builds on its assumptions. Is that a dog? Oh yeah, totally, that's a dog. Yes, it's a dog, but like a dog with bug legs? It's like a bunch of stoned people looking at clouds and seeing pictures in them and agreeing with each other. It misses the big picture and only looks at the small parts and builds a story based on those sections. Style transfer is the machine learning art of making something look like it was made in the style of something else, as if a long-dead artist had painted your photograph. A neural algorithm of artistic style by Gatiss, Ecker, and Bethke is the seminal work on style transfer algorithms, where it builds on the capabilities of Deep Dream. They're also the creators of the website deepart.io, where laypeople can come and use their scripts in a web-friendly interface. Historically, I've used a torch implementation of this concept called Neural Style by J.C. Johnson. It allows me to see every iterative stage and fine-tune my own parameters to get the results I'm after. I now use a Python one on the TensorFlow network, and I'm very excited about a new PyTorch style transfer based on J.C. Johnson's work that has just been released. Style transfer may be based on similar technologies to Deep Dream, but it's resulted in fewer people being horrified to look at their social media feeds. Some users have created some truly excellent machine learning-based artistic creations, like these dinosaurs made from fruit and flowers by Chris Rodley. They were made using deepart.io and went viral last year, introducing the concept of style transfer to thousands who had never heard of it before. These were made by crossing a book on flowers or a book on fruit with a book on dinosaurs, and successfully carried the essence of both across, and they exist in synchronicity together. Reddit users have found this style transfer more unsettling. It's of Napoleon crossing the Alps and is highly successful, but has also been hailed as highly creepy due to every element being comprised of unexpected fabric folds. One of the things I find amazing about working with machine learning is when things turn out very differently than expected. When a color emerges that wasn't there in the style image or the content. When things like that run off the rails, I feel amazed because it opens my mind to new possibilities and new ways of looking at things. This work is from an untextured render and a Python semantic photo style transfer in TensorFlow of a stream. The colors are all very natural. There's an obvious correlation. But this is what the machine did. I mean, these colors aren't anywhere close to anything expected. It's beautiful. It's a galaxy of colors, but to get from here to here seems like a bit of a stretch. But when you watch it in animation, you start to get a feel for how it happens, how the browns develop and turn pinkish, and the algorithm builds on its assumptions in a deep dream-like way to create a totally unexpected outcome. Now, admittedly, I'm not using this algorithm for its intended use. I'm purposely twisting it about to create something of my own, and I'm getting unexpected outcomes as a result. But that's glorious, and it's totally as it should be. We shouldn't be afraid to change things up for our own use. If we can see an application that's a bit outside of the box, we should totally go for it. Generative adversarial networks run in a similar way to artistic critiques or code reviews. A producer creates something, and it's immediately critiqued by its adversary. Like academia dialed up to 11, but neural networks don't have feelings. At least not yet. So we don't have to worry so much about that. The process is repeated over and over, and the machine learns the best ways to produce work to fit the definition and criteria. In that way, we may discover more about what makes art art. GANs are the very definition of I know it when I see it, but without emotional or political bias, it can determine artistic quality for itself. While in this way we may learn more about the artistic process and development, we may also run the risk of GAN producers restricting themselves too much, like an artist who finds out that only one thing sells and produces nothing but that for the rest of their career. In machine learning, we call that mode collapse. In the art world, we call it Thomas Kincaid. We need to strike a balance between encouraging imagination while still allowing it to exist within the loose category of art. We stand on a new precipice of artistic discovery, just as we did after Duchamp declared, the artist of the future will merely point his finger and say it's art, and it will be art. And while many disagreed and were outraged by his works, it heralded a new way of looking at art. And we're yet again looking at a new way to look at art and art creation. Pix2Pix uses conditional generative adversarial networks and is set up to translate images from one thing to another. That may be using style transfer, colorizing black and white images, changing day to night, generating a city from a map, but it's best known for filling in sketches with photographic data. This last example went viral online. When a web interface went up for everyone to sketch cats and shoes and handbags. There was even a very brief portrait one, which has recently resurfaced. It's so much fun. Again, like Deep Dream, everyone responded to this creepiness, the horrible things that could be made and shared around to laugh at, and it is so fun. It's really cool. Someone created a beholder cat, by the way, which is glorious in every way. But where many see a creepy and short-lived option for entertainment and nightmare fuel, artists such as Patrick Tressett are seeing the possibilities for high-end art. This GIF is from Patrick's work with Pix2Pix, training his own conditional adversarial network in a series of sketches produced by robots during an installation and the photographs of people sitting for their portrait. It doesn't get cooler than that, robots creating sketches of people. But then he produced his own sketch and submitted the video to the CAN, and this is the result. It's otherworldly, almost painterly. With a decidedly digital feel, it takes on a sense of evolution. Each work is a unique thing, but viewed together as a progression, it's a new expression of collaboration between human and algorithm. Apps such as FaceApp Apps such as FaceApp are a fascinating look into mobile-based applications of machine learning. They're frivolous, for sure, but they provide insight into notions of beauty with a spark setting. They provide insight into gender with their gender swapping filters and aging and the forced smile. They go beyond Snapchat filters and Photoshop morphs to fundamentally change aspects of the face and create apparently as seamless an experience as possible. These ones, not so seamless, but the results from FaceApp that have gone viral have been from toys, statues, and paintings. And people seem to be a bit grossed out by the way it forces a smile onto people's faces. But if you look to how it attempts to match the style as well as the smile, you can see where it really starts to become successful. MugLife is the latest facial manipulation app offered by NVIDIA. An attempt to make a 3D meme GIF generator, it uses machine learning to detect facial data and then create a mesh with your photograph as an overlaid texture. From there, you can manipulate it yourself or use preset animations. On the face of it, it's a really silly concept. And the user interface and meme content don't inspire a lot of confidence in the back end. It works well on subtle animations, but not well on large ones or with people with glasses. But the technology behind it is really cool. there's a lot going on behind the seemingly banal interface. I find that with anything involving machine learning, the fails are almost as interesting as the successes. This is a photograph a friend took of a statue of baby Jesus. The mesh applied poorly in this case due to the angle of the face, and somehow the mouth ended up in the neck to create this gaping maw. For some reason, it's also supposed to say, "You mad, bro," but for some reason the text also failed, creating this bizarre Simlish caption. This one GIF gave me so much hope for this app. And just like with FaceApp, it works really well bringing art to life. The exaggeration and ridiculousness of the work particularly works well in this scale. And this inspired me to see what it could do with portraits people were generating with GANs. Oh. I'm sorry. I find this delightful. Not only because the facial recognition works so well, but because it allowed me to have a conversation with Mario Klingerman about the works. He uses Pix2Pix trained on old masters for this series and uses it to transform live webcam results or to create reconstructions. This particular work was a reconstruction of Ecce Homo and is one of the magical aspects of all of these machine learning projects that come together to produce something unsettling, weird, or hilarious, or maybe all three. Now, this is one of my hands-down favorite things. It's a Christmas carol composed in 2016 by showing a recurrent neural network a picture. The internet blew up with tales of its creepiness and proof of how AI is going to murder all humans. But this is an independent creation by a machine after being inspired by a picture. It's a reaction to a stimulus to create something different. It has some issues. It interpreted the decorations on the tree as flowers, but there are glimmerings of Christmas carol sentiment appearing around the edges. This work was created in Berkeley AI Labs as part of their Neural Karaoke project and as part of a greater project involving composition of pop music and story singing such as this. The reaction is almost as fun as the work itself, and that is part of the controversy in machine learning-based art. The online nature of the work opens it up to response, and the response becomes part of the work. This Christmas carol inspired me so much. It's the core of the work I'm producing at the moment. Using a deep convolutional generative adversarial network to generate works based on Greek and Roman statuary, I'm then submitting them to a neural storyteller, which generates a small story based on what captions an image classifier sees. The DC GAN runs on TensorFlow, and the storyteller runs on Caffe, but both use Python. These works are forming part of a series exploring gender through the lens of computer vision. I'll then be reinterpreting these works on my own and seeing what the storyteller creates in response to this. A perfect collaborative cycle going back and forth, gaining inspiration from unexpected sources. In my case, I'm particularly delighted with the way gender is a completely fluid concept in machine learning, and that's really the core of the research I'm doing at the moment. I'm completely enthralled by it. One of the most interesting ways to create art with AI is to chain together different machine learning projects, whether in language, classification, or a series of art generation ones. New processes are emerging to bring together different projects to fully explore the capabilities of art creation. Artists such as Robbie Barrett, Mario Klingerman, Mike Tyker, Tom White, and myself all use multiple techniques chained together to create a final work. Mike Tyker is one of the engineers behind Deep Dream. These inceptionism works were created using Deep Dream and random noise, and neural networks trained on patterns and cities by the MIT Computer Science and Artificial Intelligence Laboratory. Since creating these works, Tyke has been working on his series, Portraits of Imaginary People. First using Deep Dream-style backpropagation approaches, it's not animating, there we go. Deep Dream-style backpropagation approaches, then moving into generative adversarial networks, he uses a deep convolutional generative adversarial network to generate faces on a tiny scale, and then a stack GAN to upsample the different parts of the face according to a generated face map, and it merges them all together in a higher resolution format. This tiling technique uses similar technologies to pix in its texturing. The final result is breathtaking. It's otherworldly. The faces are human and yet just somewhat other, with a painterly aspect to the texture that gives them a sense of soul. Where does the medium lie in digital art? Is it all ones and zeros, or something that transcends the foundation it was built upon? Do people see more value in a work where they can see the texture and the brushstrokes and the touch of a human hand? Do we dismiss things on the screen more often than not because we conflate our screen exposure so that all digital experiences are given equal weight? What of the work the next Rembrandt created entirely by computer? This work was produced by code that utilized deep learning to analyze every known Rembrandt painting until it came up with a perfect collection of characteristics that made up a Rembrandt portrait, from the gender to the posing to the lighting. The computer then sampled and processed the details to create an entirely new work based on the previous works of Rembrandt of a person who never actually existed. Where did this person come from? If this is where the portrait had stopped, then it may have been dismissed, but the work was taken further to produce a topographical plan based around brushstrokes and Rembrandt's specific paint application style. It was then 3D printed in layered and textured inks. Is this a more valid work by this rationale, as it exists in a painted, tangible form with texture? Is it more real somehow than a work that exists purely on a computer? This is an issue I grappled with as I created my first project. I wanted something physical, but also something entirely digital, an aesthetic display for white wall gallery hanging, but an exploration of machine learning and an analysis of post-gender concepts in a digital space. For me, augmented reality was the solution allowing me to bridge those worlds. I craft models in DAZ 3D and Blender, and from there I take the final render together with the original inspiration behind the work, such as archaeological artifacts, paintings, things I turn up in my research, and I use neural style to create a machine learning-based interpretation of that work. The simplicity of the interaction shouldn't detract from what it is. When you hold your phone up to a piece, the work fundamentally changes. And when it is seen with its partner fretwork, where it begins from an abstract space and loops back to the original render, you start to gain an idea for the notion of transition. I didn't want to create a work on transness where the figures transition physically. This work isn't about that. It's about being who you are, how your inspirations and the things you see become part of you, and how, when you look at yourself, you see parts of everything you've consumed visually coming together. And that is why machine learning is such a wonderful tool for artists to use, because everything we absorb ends up in our work. Knowingly or unknowingly, we train our minds and spit out the results. Some are resolved and well executed, and some are gibberish. But our art is the product of what we absorb. Enter neural networks and the ability to train it in specifics, art from a given time, pictures of flowers, colors, shapes, faces, smiles, and we gain the power to collaborate with the computer in incredible ways. The questions that arise when looking at these works is, can computers create art? Are these works digital art, or are they a flash in the pan? Are they merely a kitsch development of some cool code, or a new way to look at the way art is made? Where does the art lie in these works? Is it in the collaboration, the code, in the works that are produced? Many art forms are similar. They rely on the artist to control as many of the variables as possible, while maintaining the freedom to allow the work to take shape. When the brush, in this case, is an algorithm run by a computer accessing the sum total of a neural network's knowledge, then the output is chaotic, to be sure. But to be able to control through knowledge and expertise, just like with a camera or with a paintbrush. An artist working with these tools still has to learn to use them effectively to produce something unique, just as a painter or a photographer would. As the old programming axiom goes, garbage in, garbage out. Neural networks at their heart are mimesis. They're an imitation of the human brain, developed to try to think like ours and make connections. The truly disturbing thing about it may be that we don't want to acknowledge that it's getting closer to the way we process thoughts and images. Whether it's mimicking the style of artists, hallucinating strange beasts, or creating a person we've never seen before, computers are drawing closer to mimicking the way we create art, to duplicating the styles made by human hands and the connections we see. We appear to be drawing ever closer to replicating the way artists view the world. If we can teach computers to see the way we do, then we're getting closer to them creating the way we do as well. If we can replicate that, if we can work towards duplicating the processes in digital art and using these methods to augment our own creative works, because when an artist is combined with an artistic computer, the possibilities inherent outweigh the capabilities of each individually. I believe there's space for the ridiculous frivolity of face app selfies, as well as the beauty and surprising complex structure of the Taika works. There's room for artists to collaborate with code to create something in between, and room for the computer to do all the heavy lifting from nothing at all. The difference is in the intention. If the intention is to create an amazing artwork, the power's there. If the intent is to horrify or amuse, the power's there as well. The algorithm treats them all the same. It can't tell a cat from a Kandinsky. In this way, the internet is an equalizer. The algorithms are equalizers, and anyone with the capability can produce works with this code. They can share them, disseminate them, share the code, print them to sell, or give them away as free viral fodder. Machine learning has the capacity to inspire, to fuel our work in amazing ways if only we let it. And in turn, we can seed that garden for others, ourselves, and watch the inspiration grow for others. Thank you.
Okay, we have a few minutes for questions, if anyone has questions.
I just wanted to ask if your slides are available anywhere?
Yes, I'll be uploading them just after this talk.
More questions?
Maybe a hairy topic, but with the use of these programs and the data sets and the collaboration, compared to something like a camera or a paintbrush, there's clearly a lot more involvement of these programs and people together. So where does the ownership of the artwork lie? Does it become the person who wrote the program? Is it the maker of the neural network? Is it the one who executed the code? Or is the owner of the computer? And is this something that you have thoughts on? I
have a lot of thoughts on this one. It relates in interesting ways because most of the code is open source. So, that's, as long as we acknowledge it, it's generally quite friendly to use there. So that's good. The data set, the individual images used in a data set, when we're talking, like for my Greek and Roman one, I have over 8,000 images of sculptures. So each image would be considered copyright, but because of the scale and because of the output doesn't rely on any one source, that copyright doesn't apply. It comes under fair use. The output could eventually, we will probably see a debate along the lines of the monkey selfie of whether the computer owns the copyright or whether the artist does. And that's going to be a really interesting, I think that there's going to be a lot of debates there on that. In the end, there's a long storied history of artists using assistants, using people to create works for them. They'll come up with the idea and then they'll have a large stable of other artists who actually make the work. Yet the artist who came up with the concept is the one who's always credited. And I think that we're going to probably stick with that format. I hope that helps.
Okay, we have time for maybe one more question.
How did you actually get started using neural networks in art? Like, what inspired you?
I got very excited by Deep Dream, but it wasn't until a friend shared some neural style things that really got me excited by the style transfer. And I was in the middle of my master's at the time and looking for a way to relate my 3D models to augmented reality in some way. And it was like, oh my God, I know exactly what to do. And so I went to the website, deepart.io, but because this thing had gone viral, it had crashed. Not DeepArt, the other one. Anyway, it crashed out of all the use. So somebody in the comments linked a repo. And I went, oh, this can't be too hard. I like to say, I kind of fell into machine learning. I didn't realize it was difficult when I jumped in, and now I'm in tooth deep. I can't ever get out.
Okay, that's all the time that we have now. Please thank Jay for their talk. And on behalf of PyCon, it's a small token of their appreciation.
Thank you. Thank you all so much.